Alright, this is our last video for Chapter 6. This is a summary of everything you've learned. There was two main ideas here, but let me get to the first one. Systems of equations. This is where you have more than one equation on the same situation. So it could be the same variables, the same graph, the same two quantities that are varying with each other. So for example, like money and height of plants or something like that. And so you might have two different plants growing, and you want to pay different amounts for them, and you want to see when do you break even, or things like that. Anyways, you always have the same two variables, so when you graph the two equations, they'll be on the same axis, and there's only three possibilities that can happen. One possibility is that the two lines end up parallel. That means they have the same slope, but different y-intercepts, in which case there's no solution because those two never cross. There will never be a single point which satisfies both equations. Another possibility is that they have the same slope and the same y-intercept, which means they're actually right on top of each other, the same line. In this case, every single point on the line is also on the other line, so there's an infinite number of solutions. Okay, both of these are pretty rare. They happen now and again, but not very often. The most common thing that will happen is your two lines will have a different slope, and they will cross at some point. Now, if they happen to cross at a perfect 90-degree angle, that's called perpendicular, and the slopes will be negative reciprocals. But more often, they just cross at some random angle, and there's a single solution where they cross. So no solution will be parallel like this. All solutions would be right on top of each other, like that. And most common is like this. And also pretty rare is a perfect 90-degree angle. So here, M1 equals M2. And then right here, M1 equals negative reciprocal of M2. So you flip it over and make it negative. That's for perpendicular lines. This is for parallel lines. Okay, there's three different methods we learned to solve them, but really two of them are the good ones. So the first method was graphing, which was nice to see on the graph where they're going to cross. Is it going to be close to the axis, far from the axis? Which quadrant will it be in? Will x or y be negative or positive? But it wasn't so good for getting exact values because you can't tell by looking at a graph exactly where they cross if it's going to be some weird decimal answer. So the two methods that really did work well were substitution. That's where you pick one of the two equations and solve it for a single variable, and then stick it or plug it into the other one, substitute it in. Or the elimination method, where you have to get the two variables to match up so that you have a positive something x and negative something x, and then when you add the two equations together, one of the variables cancels out. Regardless of whether you choose substitution or elimination, once you get past that first step, everything else is the same. So let's move on to the problem-solving steps. As I was just saying, so once you finish that first step, either substituting or eliminating a variable, you end up with an equation with just one variable, because you've eliminated by substitution or elimination the other variable. Once you have an equation with one variable, it becomes very straightforward. Solve to get a numerical answer, and then always remember to plug that back into the original. Okay, so this is a critical step. Once you have the first number, either x or y, plug that back in, and you could pick either equation, doesn't matter, remember, because this answer has to be on both of them in order to be a solution. And then the last thing that a lot of you guys have been forgetting recently is to write your answer as a coordinate pair. So say you have x equals 2 and y equals negative 4. You want to actually write 2, negative 4, because what you're saying is, if you were to graph these two lines, they would cross at the coordinate point 2, negative 4. If you plug these values in, then of course it will work as well. For inequalities, everything is the same as equations, except you have to remember to do either a shaded line, either a dotted line or a solid line, and then you have to shade above or below. So you're shading, God, I can't talk today, sorry. Shading above or below the axis, and you want to graph both of them on the same axis. So you'll graph two, you'll shade maybe above this one, and also above this one, and so your final answer is right in here. Your shaded graph is your answer for these inequalities. And then the last thing is to remember to use Desmos.com to check your answers, exact values, and also just to visualize what should be happening. So I'm going to try to do maybe one example right here. Suppose we have a system of equations. 2x plus 6y equals 18, and maybe x minus y equals 5. I have no idea if this will work out nicely or not. I just made it up on the spot. So when you look at this, the first thing to check is neither one of them is solved for a single variable, so it's not set up that well for substitution. However, there's an x by itself right here, so you could easily add y to the other side, plus y plus y, and you'd get x equals y plus 5. And now you could take this and substitute it in right here. And if you did that, you'd get 2. And instead of x, we put in y plus 5. Remember, it's very important to put these parentheses around your substituted value. Plus 6y, again, I'm coming from this top equation, equals 18. So here we can go distribute 2y plus 10 plus 6y equals 18. I'm going to combine the 2y and the 6y to give myself 8y, and I'm simultaneously going to subtract 10 on both sides. 18 minus 10 is 8, and actually it worked out nicely. Y equals 1. Okay, and now to get the x value, I have this equation right here where it's already solved for x. So I can go x equals y plus 5. Well, y was 1. 1 plus 5. X equals 6. And then I can say my final answer is the coordinate point 6, 1, with parentheses around it because it's a coordinate point, and a box. Now I could plug this back in up here just to verify. 6 for x, 2 times 6, that's 12. Plus 6y, 6 times 1 is 6, so that's 12 plus 6 equals 18. And 6 minus 1 equals 5. So you can just check and verify. Now alternatively, I could try to solve this exact same equation using the elimination method. So let me copy down the first one. 2x plus 6y equals 18. Now to make these 6y match up with a negative y, I can multiply this whole equation by 6. So I can go multiply by 6, and I'll get 6x minus 6y equals 5 times 6 is 30. Okay, now when I add these two together, those cancel out because they match up, a positive 6y and a negative 6y. And I've got the 2x and the 6x, which combines to give me 8x equals 18 plus 30, 48. Divide by 8, divide by 8. Remember to show our work. X equals 6. Okay, and I got the same thing. And so from here I could plug the 6 back in over here to either of these equations or any of these equations, and I would solve, and I'll get y equals 1. Of course I'm not going to show that since we already did it once. But the point is you get the same answer regardless of which method you use. So in many situations it comes down to which one you're more comfortable with. Obviously you have to know both right now, because there are certain situations where one or the other is far easier and will save you time. But in a lot of cases you just need to use what's comfortable for you and keep practicing them, and then always remember to plug your answers back in and check. I think that's a good wrap up for Chapter 6. Always feel free to stop by office hours or ask questions in class. Alright, see you later.